This is a screencast for CA1 of C++ to build a text-based adventure game engine. I'm Cormac White. I built this with Kieran Hoy, who can't be in the screencast currently. He's going to email for reasons of that. Firstly, we use GitHub to track our progress and share the code base between the two of us. Just over 80 commits there. We used GitKraken to as a local Git client for uploading to GitHub and sharing. The actual code itself, so this is our main, and we create an engine, as you can see here. For our engine to function, to run it, we need 4 things. We need a player character, a current room that the player is in, all rooms in the game, and a vector of integers called room ID visited. That's for stat tracking later on. So firstly, create a vector of rooms. This is just an empty vector of rooms, the room class in here. So a room takes in, a room inherits from a parent called object, which all classes in our game inherit from. So we've a fairly in-depth inheritance system. Each object has an ID, a name, and a description. So a room has those as well. It also has a vector of dynamic item pointers, a vector of character pointers, a vector of scenery pointers, and a vector of connected rooms. All of these classes have been made as well. So dynamic item is made here. So dynamic item inherits from an item class, which is here, which inherits from object. So item adds a value, a monetary value to the item. Dynamic item adds a state and a use, because dynamic items can change state and have different amounts of uses depending on how you use them. Dynamic items split into 3 further variants. Weapon, as you can see here, is one of them, and it adds unique variables for weapons, including attack, defense, and speed of the weapon. Other ones are keys. So keys just adds a lock ID, which matches an ID to a room ID to unlock a room. And the other one is consumable, and consumable are like potions, and it adds an enum called consumable type and an effect value for that. So the enum consumable type is here, and we just have it set that there's 2 currently, a health potion and a health poison. The idea being that can be expanded to other types of consumables. So on top of, so those are the 3 types of subclasses from dynamic item. After that, you've got characters. Characters again inherit from object, so you've got your ID, name, and description. After that, characters have a health value. A character has an item patch or an inventory, which is a vector of dynamic item pointers. A wallet to track the amount of money. A state, true or false, for like if the character is alive or dead. And it also has a left and a right hand equipped, so what items equipped in the left and right hand. Character also splits into player character and enemy character as well. After character, you've got scenery. Throughout this project, I've accidentally misspelled scenery, putting an A instead of an E, but it all still works, and it's just spelling error. It inherits from object as well, so you've got an ID, name, and a description. After that, you also have additional dialogue for scenery objects and a state, with the idea being you can look at and inspect a scenery object, but you can't take it or remove it. And the state is if you want to disable it for some reason in a room. So that all leads back into the room, and that explains dynamic item, characters, scenery. The last one is connected rooms. So connected room doesn't inherit from anything. It just takes a room ID, stores a room ID, a direction type. So direction type is another enum. We've got our 4 cardinal directions, and northeast, southeast, southwest, and northwest as well. So it stores one of those 8 values, and if that room is locked. So in room, we store an array of these to keep track of which rooms you can move to, and if that is locked variable is set to true, well, you can't move through it unless you've got a key with a matching room ID. So that's how you use keys. The engine itself has quite a lot of functions. So the first one you meet in main, as you go down, is actually engine.loadGame from file. And it takes in our empty vector of rooms, and it's actually taking in the empty vector of rooms. And as you can see down here, load game from file, we're actually just taking the address of that. So we're going to change, we're going to store all the rooms from a file into here. So the file itself looks like this. So here's this is a file that we're using. As you can see, it kind of looks fairly confusing, but we've got a delimiter system to work out where a room is and where each variable inside that room is, characters, etc. So that's what the actual file looks like. So when you call this function, loadGame file, in the engine.cpp file, it calls loadGame, which we're using a bit of code that found on Stack Overflow to take the file in an string game file and convert it entirely into a single string. Other methods that we tried would only convert either the first word without a space, or it would convert the last word with a space before it. So this method here works for us to get the entire game file into a single string. We then split that into a vector string called rooms, using this as our delimiter. That splits it into, in our current version, 5 rooms. So for each room, we then split that further, and we know the order of the variables. So we set each of the room variables. So that's our ID. So we're using a string stream to take the string stored in the vector and then push it into an integer value. And then we clear the string stream straight after because we'll be using it again. We store the name, description. We store all the item information into a string, all the character information into a string, all the scene information into a string, and the same with connected rooms into a string. So for each of these last 4, we create a dynamic item pointer vector for our dynamic items, a vector character pointers for characters, scenery pointers for scenery, and just connected room. We don't need a pointer for a connected room. And for each of these, we take the string value, as you can see here, and we split it using a tilde as our delimiter, and we get vector strings. So for each of these, we have a function called populate item vector. Populate item vector, if we jump to the definition, is a loop for each item to push back into dynamic items using an address to that pointer, and calling populate item, which is just the actual function. Doing a similar thing with what we did with room. We go in, we know the order of our variables, we split all the strings again. We split all the strings inside the item to split up the variables, using that string stream again and clearing it, setting all the variables. Interestingly with item, because there's 3 types of item, we then have to work out which type of item based on the size of the vector. So if there's six variables is what a regular item has. A key has an additional 7th. A consumable has 8 because it has 2 more. It has a constant type, a consumable type even, and an effect variable. And finally, a weapon has 9, a size of 9 in its vector because it has attack, defense, and speed. So that's how we work out which type of item to create. Now each of these returns create weapon, create consumable, or create key. This here, if we just go to it, go to the definition, all it does is it returns a new weapon with those specifications to create a pointer to return. So if we jump back up to populate item, when populate item is finished, it jumps back to where we're creating our character item. So let's say populate, close that, and close create classes. So load game back in here. So after it does this here for item, it does the exact same similar setup for character, also splitting between player, NPC, and enemy. Then scenery is straightforward, there's only one kind, so it does the same thing there. And then connect room vector does the same, only difference is it's not a pointer. When it gets all of this information back, we then push the room with all these variables into all room. So it does this for each room you have in the file, and then it closes the file. So in main, at this point, all of our rooms have been split up from the file and stored in all room. After that, we set the current room to be the address of the room, where using the function that's inside engine, get room ID with player. So if we go to this definition, it goes and cycles through each room that's inside the vector all rooms, and if there's a character that equals let's jump to this definition. Yeah, so if there's a character that equals an ID of 1, because player character is always ID 1 in our game, then it will return that room as being the room the character is in. So we get our current room. Room ID visited is just an empty vector of integers setup. Then we push back current room get ID because we're in that room. So we visit it. We then create a player, our player character, and set it to be the engine get player. So if we go back to here, you'll see that it's the same function again, returning the player character because we know where it is now. It's inside the current room. Then we call engine run, which runs our game. We pass in our player, current room, all rooms, and room ID visited. So the run function is pretty big. The run function basically encompasses the entire game and all output. So it starts off with just saying, now you begin your story. After that, we set up 2 strings, a verb and a noun, and we have a while loop with a check integer. We could have used Boolean true false, but we just set it up as an integer for now. In this loop, the player is asked to enter their command, and then it takes in the next 2 words worked out with a space character in between. So we then convert those words, whatever they've typed in, all to lowercase. So if we go here, definition, we're using toLower to take each individual character in a string and lower it, and then send back the new string. So this new string, back up here to the top, these new strings for verb and noun are checked. So verb has specific commands. It has if, pick up, it has go, pick up, look at, use, view, help, and settings. So for go, we then call another function called checkItDirection, which checks to see if the noun entered after the verb is a valid direction from our list of directions. So we can go and check that. So we go to that, we have, it's a boolean, and it returns if the string is any of the following values: north, northeast, east, etc. Right then, and if not, return false. Once we have that checked, we can then go, because we know it is a direction it can go in theory. We then get the actual enum direction type direction based on that string that they've entered in, and we have a function for doing that as well. We then set up, we then go and check to see if any of the connected room IDs, the connected rooms that are stored connected to this room, match the direction of what the player entered. And if it did, if it didn't, we output no rooms due in a direction, so no rooms due south, no rooms due north. If there was one, we just output that one, and what we do is we call a function called change room, which takes in a number of variables to basically, if we go to it, we're taking the player object, the character object, player, and we are moving it into a different room vector and removing it from the previous one. So change room does a couple of checks, and then when it's happy that the player is actually moving into a room it's allowed to move into, we add the character player to the destination room, and we remove character player by its ID from the current room, and we output that the player's name, whatever that is, hero, left the current room and went to new room. And if this fails because they've entered something incorrectly, we output no valid room in that direction. So that's if there's one room that's output in the same direction, because you could have two doors leading to two separate rooms in the same direction. So if there's multiple rooms in that direction, we do a printout of each one with a number after it, and then we say enter the number of the room. So if there was 3, we enter 0, 1, and 2, and the name of that room. And if you want to go to that room, you enter the number, and we call the same function change room, and it moves you into the new room as well. We then do a couple of checks to see if this here is for your room ID visit for the stat. If you have been in the room before, then it'll already have it in its vector, and if that's true, then it won't pass back that it's after going in. So for the first time you go in, it'll pass back the ID of the room you're visiting, keep track of how many rooms you visited in total. And if you didn't enter a correct noun, you'll get verb go can only be used with direction. So that's go. Pick up lets you pick up items from any room. So what we're doing here is fairly straightforward. We are checking if the item name, noun, that you entered is in the current room. So we set up vector strings called item room list, and we store the name of every item in the current room in lowercase. We use that 2 lowercase again in here, because noun's already been pressed to lowercase. So if we loop this through, so for every instance of an item with that name, if the name you've entered matches that item, then output the item was added to your inventory, and then we actually add it to the inventory. So we have another for loop, and we go through all the items in the room. If the name matches the current item that we're on, we then call the player function pickup, and we call the current room function remove item. So player function pickup, go to that definition, it's in a character, and it just outputs you picked up the item, and it pushes back that item that the address of that item into the item pouch. On top of that, the other function is called the room function remove item. So this removes an item from a room. So go to definition. So this here goes and takes the item ID. It loops through all the items in the room, and when it finds the item with that ID, it erases it from the item vector in room. And if it can't find an item, it outputs there's no such item here. After pickup, there's look at, which has a lot of uses. You can look at your inventory, and it just prints out your inventory, looks at the room. It prints out what we're calling a soft print. So if you go to soft print, it just prints out just enough information that you'd want to give to the. It's not every single variable that we could print out. We've a greater print here, which prints out a more in-depth analysis of a room for debugging. But this is what you want to print out when you're playing the game. So it prints out the name of the room, the description, and then it prints out just the names of the items, just the names of the scenery, just the name of the characters, and it prints out information due to connecting rooms. So the way that those are printed out, it'll tell you that there are a certain amount of items, the item names, how many scenery items there is, how many characters, and the names of the scenery, the name of the characters. And then for connecting room, we print out there is a room due and in the direction of each of them. So there's a room due north, there's a room due south, and how many connected rooms there is in total. So that's how we're doing soft print. After that, you can view scenery. So if you type in scenery after look at, it'll print out a list of all the scenery names and then ask you want to investigate one in particular. If you say yes, you can enter the name of that scenery item that you want to investigate more closely and view in-depth information on that one item. Here. Similarly, you can do the same with characters. We can print out a list of characters. You can specify a character you want to print out. Same with items. But if you just want to type out look at and the name of any of those, so scenery, characters, or items, you can use this else. So it falls in here. We create a vector string for all the items in the room, all your items in your inventory. On top of that, all the characters in a room and all the scenery in a room, and we're pressing these to lowercase as well, so we can check against them properly. So then we just have an if case. So if the items in a room list is greater than 0, so if there's at least one item in that room that matches with our noun, we then call this function, and for each of them we say found in room, and then we print out the information on that item or that character or that piece of scenery immediately. So you don't need to specify like look at character and then say the name. You can just say the name of the character, look at, and the name of the character. And if you type something that doesn't match anything, it says there's nothing with that name here. And again, these are room specific. So if you change room, you can view and look at all the other stuff in that other room. On top of look at, you've got use, which works with items. So if you have an item in your item pouch, you can use it. So you call use item, and it runs through this function. So use, and then the name of the item, sorry. And similar to above, we have the other version as well. But in this case, instead of calling print, it calls use item. So use item in this case, if you go to definition, it's an if statement. So if the uses of the item is greater than 0, so if it hasn't been used up, there's a durability to an item, then we print out that the item name was used, and we decrease the item uses by 1. And if not, we print out that the item is broken and it cannot be used, and we set the state of the item to false, so that in future checks we can use it for if an item is destroyed entirely, like a key item. So on top of that, that's just in dynamic item. Weapons, consumables, and keys have slightly different outputs on top of this. So this here use item is a virtual function in dynamic item, and it's in weapon we override it. So you can see here we override use item. We also do an override on the print as well. But use item, I'm going to show you how that's used. So down here you can see we call the use item in dynamic item to get that information from before, and we also call you attacked with the name of your item, name of your weapon, dealing whatever attack damage. Now we have a function here. We had to comment it out because there was an incident, we were trying to pass in the all room vector into use item and dynamic item in here, and it was breaking our code for some unknown reason. But the idea would be that this here asks you which character you want to use your weapon on, and you select the character in the current room. And when you use it, it'll say you attacked the name of that character with the name of that item, dealing an amount of damage. And then we say if the character health, we set the character health, get health minus the attack damage. And then if character get health is less than or equal to 0, so if it ran out of health, we set their state to false to mean dead. So if you then try to attack it again, it would go here and the state would be false, and it would call it else, and it'll say character name, character state. So that's how we're using that. So that's how you use. After that, we've got view, which is just for viewing stats. So if you say view stats, we have a number of unique rooms visited using that room ID visited vector before. We just print out the size. It works out every time you move a room if you've been there before, and if you haven't, it adds one to the vector. It's just the ID. After that, we also have a number of items in your inventory, so we're just getting, again, the size of the vector for the item pouch. The number of times an item has been used hasn't been implemented. We were going to implement that, but that's another one we could have done. The total value of items in inventory. So this one here is interesting. So we set up an integer called wealth value, and for every item in the player's inventory, we add the value of that item to wealth value to get the total value in coins if they were to sell all of their items in their inventory. We also get the health and the wealth using get health and get wallet from player. So that we also then have, if you just want to look at those individually, if you type in view health, you get that, and or view wallet, you get that. So after view, we've got help. So help controls just gives you some info on the keywords you can use. Go pick up, look at, use, view, and the directions there are in the game. After that, we have space where we're going to write in information about a room like class or room object, an item object, a character object, and a scenery object. And they're there if in theory we continue on this. And after that, we've got settings, which the idea was, we never got to implement it, that you have the option to save to a file, load a file, or quit. So we have quit implemented. The other two, save would require us writing a method to basically pack all our variables into a string and then push into a selected text file. And load would just be calling that initial function we have in main, load game from file, but we have the option for you to enter in a file name. The quit asks you if you wish to save. It gives you an option to confirm your entry of quit. So if you accidentally typed quit, or you just change your mind, you can cancel quitting. And that's basically how our game functions. So I'll just show you the game now. So if we load it here, and just increase the font size. So as you can see, we've got now you begin story, enter your command. So the first thing I want to do is look at the room I'm in. So we get this here, this is our soft print, and gives us a room name or description. It tells us that there's one item in the room, there's one piece of scenery, there's one hero, and there's 3 connecting rooms, one north, west, and east. So let's have a look. The item in the room, there's a twig. So we can say, look at twig, and we entered look at twig, and it says it was found in the room. We looked at the twig, it gives us the name, the description of the twig, item value, and uses. So say I want to pick up the twig, so pick up twig. The twig was added to my inventory, and it says you picked up the twig. So let's check to see did it add to the inventory. So look at inventory, and you can see here the inventory is quite big. How do I type in look at inventory? Look at twig. Look at inventory, item patch, yes. So we've got we already had an item called milk with these values, and here's the twig that's been added to that vector as well. and you'll notice that it's actually a consumable. We can eat the twig, which mightn't be great, but we can use it. So use twig, and we can see twig was used, which is the dynamic item function, and then it's overridden by consumable. The twig is consumed and your health increases by 2. So apparently this twig lets you increase your health. Let's say you want to go in a direction. So I've actually forgotten. So just look at room. Where are the doors? There's a door north, west, and east. So say we want to go east. When we hit go east, it'll say hero left the name of the room and went to Mystical Fountain Room. So there's the next room that we're going into. That's the name of the new room. And now we're confirmed you are now in Mystical Fountain. And to check that, we're going to just call that same function look at room that we just did before, and we'll see this is a completely different room with different items. So there's a water item we can pick up. There's a fountain scenery. There's a separate character called Saria. And there's 2 connecting rooms, to the west where we just came from, to the north. So let's say I want to go north. So go north. And now we've left the Mystical Fountain Room and went into the Ming Dynasty Room. So I'm guessing we can look around here as well. So look at room. We have we've got 1 item, a Ming Dynasty vase. We've got 1 piece of scenery, the podium it's sitting on top of. We've got another character in the game, and we only have 1 connecting room, so just back the way we came. So let's pick up the Ming Dynasty vase, or let's look at it first. Ming Dynasty vase. We can see it's in the room, and we have the name, the description. Ming Dynasty vase, it is truly priceless, and in our game, priceless is 1 million coins, and that's its durability as well. So let's pick it up. Pick up Ming Dynasty vase, and you can see it was added to your inventory, and we picked it up. And just to check that, look at inventory. And sure enough, we've got our milk. Then we have that twig from before, with 1 more use left on it. And we have the Ming Dynasty vase. So just one last thing, we're going to say, look at Ming Dynasty vase again, because it's now in our inventory, not in the room. And you'll see it now says found in inventory, and it gives us the information. So we can specify each individual item. Let's use the twig again. And the twig was used and it was consumed. And look at twig, and you can see it has 0 uses left. So if we try to use it again, use twig, the twig is now broken, it cannot be used, so we can't actually use it. So if we go south, we can leave that room behind, and then finally just maybe we can look at a character. So look at characters. So there's 2 characters, Saria and Hero. So let's look at ourselves. Yes, I want to inspect the character. I want to inspect Hero. And here is in-depth information on Hero. So we've got the name Hero, the description, Hero of Time, health, we've got 100 health, our wallet, how many coins we have, that item pouch from before, which is now filling up, and what's in our left hand, we've got a sword, and what's in our right hand, we've got a shield. So that's basically it. And finally, we've got help controls, which is showing us our different keywords. We also have view stats, which is showing us we've visited 3 unique rooms. So we've actually moved maybe through 5 rooms, but they're actually just 3 rooms. We went through 3 unique rooms and then backtracked twice. The number of items in our inventory is 3. The number of times we haven't set that up yet, but the total value of the items in the inventory, we have a value of 1,000,008 coins, and it gives us our current health and our current wealth. Finally, we've got settings quit, which lets us confirm yes or no if we're going to quit, and in this case we do yes, and the game has ended. And that is basically it. So I'll just show you this again. If I can just increase font size. So here you can see, if I break it down here, so each room being broken up by backslash, giving you the ID of the room, name of the room, the description of the room, which goes to here, Then we have, so we're using the dash as a delimiter for each variable. Then this dash goes to here. So there's the item in the room, the twig, and each of those, the pipes is delimiting the variables for that. Then you've got player and player ID, name, description. Then it gets to here, and from here on, it's doing from about here. This here is the inventory. So each item is broken up by a comma, and then if you have multiple items, we use the num tag there. After that, the final couple of variables, and then again using commas for the left-hand item and the right-hand item. After that, we have our scenery items, which you can see here. Go from here over to here. And finally, these last three here, broken up by tildes, are actually our connecting rooms. So that's the room ID that it's connecting to. So this is room 0. It's connecting to room 1, as you can see here. The direction, so 0 to 7 translates north, going around clockwise back to north. So in this case, it's connected to the next room north of it, and the room is not locked. And this one's connected to room 2 to the west, I think. Yeah, west. And it's also not locked, and room 3 is to the east, not locked. Similarly, it goes on for the additional rooms, and obviously it's just a text file, so you can probably keep going forever. So that is our project. That's pretty much everything.